Hello everyone, welcome back to my channel. This is Cherry. It's been a while since we finished our previous question. Because recently I am working on my job hunting process, so it's very important for me. So I'm very busy recently. So now I'm going to continue my plan. So today's question is 82. We need to remove duplicates from a sorted list. So we are given a sorted list and we need to find those elements, those duplicated elements, and we need to remove them. So let's take the first example. Let's use the first example to elaborate the whole process of how to fix this problem. So here we have this linked list and the number 3 and the number 4. These are two duplicates, right? Because they appear in the sorted array for more than once. So we need to delete these elements from our sorted list. Okay. Actually, I think the easiest way to solve this problem is to traverse through the sorted list from the left to the right, and we need to record the duplicate element, and then we will remove it. So how to do that? So actually, I'm going to use a new head or new, how to say that, to use a node to help you build a new linked list, right? We need to use a node to help us build a new linked list. And then when I found then I will start the traversal from the left element to the right element, and then I will just record the count of each element. So if the count of the current element is equal to 1, then that means this number is unique. So what I need to do is just to move the current node to our new linked list, right? I hope you can understand my explanation. So in order to make the whole process more clear, I'm going to code directly. Okay, so let's get started. So actually, first, the original linked list might be an empty linked list because the constraints told us that the number of the nodes in the list might be 0. So the base case is that if our current linked list is an empty linked list or is none, that means what we need to do is just to return none or return head, right? So this is our base case, and then we need to use some auxiliary variables to help us build the new linked list without duplicates, right? And so I'm going to use a variable name anchor, and I will just give it a node. Yeah, this is our auxiliary node that help us to build our new linked list. And then I will use another variable to help us traverse through the linked list. So I will use p to help us traverse. So how to traverse? I will continue to traverse our linked list until our p points to the end of points to the tail of our linked list, right? Which is none, right? So then I will record. Currently the p points to the first element, and I need to know the node itself and the current value in this node and the the number of current value. I will use a variable to help us to record. So the current node is P, and the current num is P dot value, and the current count is 1, right? And then we'll use I will write another while loop to help us count the number of the current node, right? So I will use, so if our current the next node of our current node exists, and then I will compare the value of the next value of the next node with the current num, right? The current num. So if the next node satisfy this condition, that means the number of our current node should be incremented by 1, right? And then we'll continue to move our next pointer, right? So now after we jump out of the while loop statements, I will compare the current count with 1 and 1. If the current count is equal to 1, which means this node, the current node, should be added to our new linked list, right? So here I will write another variable, which is L. Okay, L dot next points to the current value, and I need to move our L pointer to the next position, right? So, and we should be very careful, because these after we finish these statements, we might enter into a situation of where our P points to an empty and non-value. So if our P or if not P, which means we need to break the whole while loop, and then in else here we also need to move our P to the next position. Okay, so I hope you can understand why we want to move our P to the next position, because here we have P points to the current position we need to add to our new linked list, right? And after we add this element to our new linked list, we need to move the P pointer to the next position, right? So that's the reason why we do it. And then maybe you think we can return the new linked list by returning anchor.next, but here you need to be very careful, because let's see, we have a linked list which is 1, 2, 2, and the answer we want is return 1 itself without 2, but because we will add our 1 to our new linked list like this, right? We want to return our new linked list. But the problem is that the current one still points to the following 2 nodes. So in order to remove this influence, remove this situation, to fix this situation, we need to make sure that the tail of our new linked list points to num, right? So yeah, so that's the whole process. Let's run some tests to check if it's correct. Yes, let's submit the result. Okay, so that's the solution of this question. Thank you for listening. See you next time. Bye bye.